All right. We're going one by one. Okay, where is the thingy? Here's the practice test. Go one by one. And again, look. Hey, Mr. Park, the quiz we just took. It pretty much is. I'm not going to spring anything new on you. You just got to be able to do it. And if I do spring something on you, it's going to be a bonus. I don't think I put a bonus in this test. Okay, here we go. Secant of 900 degrees. So again, the angle is bigger than 360. What do? You subtract a multiple of 360, which would be what? 360, 720, 1080. So subtract 720, what do you got? 180. Okay, now where is 180 degrees? Right there. So the coordinates of that point would be -1, 0. Now secant is the reciprocal of cosine, right? Cosine is the x coordinate of this point. So cosine is -1, right? Yeah, so secant is the reciprocal of that. What is 1 over -1? -1. There you go. Boom. B, cosine of 47 pi over 3. You want me? I can make the numbers like really big. Since you guys are class of 2017, well, 2017 pi over 3. Why? This just makes me too. Whatever. Change that to a mixed number. Come on. 15 and. Thank you. So what would be a good multiple of 2 pi to subtract from that? 14 pi, right? So what is 15 and 2/3 minus 14? 1 and 2/3, which is 5/3. So cosine of 5 pi over 3. And do we know where that is? Yabba dabba do right there. So again, you draw the triangle. And again, look. Hopefully after a while, you don't have to put the coordinates of the point because we only want the x coordinate. The x coordinate of this point, how much do I have to go to the right? 1/2, so positive half. And there you go, that's the answer. We don't even have to flip it over. C, cotangent of -30 degrees. Hey, if you guys want to take a picture of the board too, you guys can. Now what is cotangent? What is cotangent? What do you guys want to do? You want to add 360 to that, or do you want to use the identity we learned? Like cotangent is 1 over tangent, right? And what did we learn? Tangent of negative theta is negative tangent theta. Is that the way you want to do it? Or do you want to just add 360 to that and get 330? It doesn't matter. See, it doesn't tell you how to do it. I just want you to compute it. Whichever. Which way do you think you would do it on the test? Add 360 or do it this way? Okay. Whatever, Danny. Okay. So if I add 360 to that, what? That's 330 degrees, which is an angle we're supposed to know. Where's 330? Right down yonder, right there. Okay. So what are the coordinates of this point? I have to go √3 over 2 to the right, and then I have to go 1/2 down, so it's negative, yeah? Now, tangent is this over this, right? So cotangent is this over this. What is that over that? Negative √3. D, cosecant 27 pi over 4. Now, the good thing about the test, I'm going to let you, since it's extended, I'm going to let you take it like over up to an hour if you want. Most of you are going to finish way earlier than that. But then you're going to have all day to draw these circles, right? So, right? You can just take your time. What's that movie preview I saw where they just take their time? Did you guys see?
Oh, the sloth one.
The sloth one.
Zootopia.
You guys can just take your time, man. So what is this? Change it to a mixed number. 6 and 3/4 pi. So if I subtract 6 pi, you're just left with 3/4 pi. So 3 pi over 4, right? which is a number we know. Where is 3 pi over 4?
Second quadrant.
Right there, right in the middle. The pi over 4 ones are the ones in the middle. So if I draw that in, what are the coordinates of the? I go 1 over root 2 to the left, and then I go 1 over root 2 up. And cosecant is the reciprocal of sine. So sine is the y coordinate. Flip it over and you get radical 2. Please don't put over 1. Just put root 2. See how easy that is? Okay, moving on. Okay, so this is just like the quiz we just took, except now you get 3 of them. So, if you made that mistake you made on the quiz by not drawing it in the proper quadrant, you're going to get like -3 on each of those, maybe even -4. Because that's the point of the whole problem, is to draw it in the proper quadrant. Okay, so number 2. Theta is in quadrant. So the first thing you should do is draw it in quadrant 4, like right here. Whoa, whoa. Now, some of you, I was looking at your pictures. You're not even drawing it like the way I did. You know, here, this is some teachers teach this. They go, okay, first quadrant you draw like that. Second quadrant you draw it like this. Third quadrant you draw it like that. And fourth quadrant you draw it like that. So if it doesn't make a bow tie, then you're doing something wrong. Does that help? Bow tie. Okay, whatever's going to work. So what does it say quadrant 4? So you draw it like this. Here's theta. Now it says cosine theta is 5/13. Now what is, and then if you have to write this on your paper, write it down. So, ka, to, a. I just saw that on a video. Where did I see it? No, it was on Jeopardy. That was a question on Jeopardy.
So,
Yeah, it said so, ka, to, a. What does the T stand for? Yeah, you can see, you guys know that. They didn't know. Anyway, cosine is adjacent over hypotenuse. You look at that one. So adjacent over hypotenuse. 5/13, and then using the Pythagorean theorem, 12. This is the 5, 12, 13. How many times does it come up on that one? And then put in the signs. These signs are like 2 points each now. Look, I have to go to the right, so it's going to be positive. But if I go down, isn't that negative?
yes.
Yeah? You have to have the sign, and the hypotenuse is always positive. Okay, so now, I forget the question. What is the value of tangent theta? Well, you simply got to look at that now. TOA, opposite over adjacent. So here's the angle. Opposite over adjacent. -12 fifths. So what if you did something stupid like this? What if you did this? What if, and then you went, what if you put, okay, never mind. Let's just move on.
-1.
No, it'll be 2. You gotta have it, you gotta have the sign. That's what trigonometry is all about, is you gotta get the signs right. Okay, quadrant 3. Here's the angle, and it says tangent theta is 4/3. Tangent theta is 4/3. So what is tangent? You look at that. Opposite over adjacent. So here's the angle. Opposite over adjacent, and that's going to be 5, right? Everybody knows 3, 4, 5 by now, right? What kind of signs do I put on? I got to go to the left, and then you got to go down.
Negative.
Oh, negative, negative. So now the question is, what is cosecant theta? Well, cosecant theta is the reciprocal of sine, right? So maybe we should figure out sine first, and then flip it over. Well, what is sine? Right here. Sine is opposite over hypotenuse. So here's the angle. Opposite over hypotenuse. -4 fifths. So cosecant, you flip down and over and you get -5 fourths. This is not that hard, Mr. Burke. And then 4. See how I'm going to make you draw it? Because everybody can do the first quadrant. Because first quadrant, everything is positive, so you don't even have to worry about it. Now we got second quadrant. Okay, it says sine theta is 2/3. Okay, now what is sine? See, that's why you write this on your paper. It's all right there. Sine is opposite over hypotenuse. So opposite over hypotenuse using the Pythagorean theorem. √5. Can everybody do that? Now, if you can't do it in your head, don't worry. Just go. Okay, call that x. X squared plus 2 squared equal 3 squared. X squared plus 4 equal 9. X squared equal 5. x equal root 5. I mean, right? Just don't make a dumb mistake and put something weird there. Okay, so I gotta go left, so that's negative. I go up, it's positive. Now, what's the question? Tangent theta. Tangent is opposite over adjacent. So here's the angle. Opposite over adjacent. 2 over negative root 5. Boom. Okay, so far I'm getting 100 on this test. Now, how many problems were on this practice test? Can I see this? Here. So this is what I do on a test. How many problems? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 23 times 4. What's 23 times 4? 92. That means you get 8 points free.
What?
Okay. Don't get no 8 points.
No.
But what were you thinking? Mr. Park, can't you just make it 3 points each? So 23, that's not 23. 23 times 3 is 69, so then 31 points free.
That's what was last semester.
Yeah, but that's Algebra 2B. We're not in Kansas anymore. Okay, second page. Hey, this looks like the quiz we just took. No, that's where I got it from. I copied and pasted and changed the numbers. Don't tell other teachers I do this. Sine 6 sine squared. That's all okay. Plus 8 sine squared. Anyway, you watch at the end. By the end, whose class would have the highest scores on the achievement test? That's right. Because everything is a contest in life. Okay, so here we go. Sine squared 45 degrees means sine of 45 degrees squared. So this is what I do. I do that first. Now, what is sine of 40? Can we do the first quadrant angles already in our head? I don't trust it. You really do it. Okay, where's 45 degrees? So after a while, you don't even have to put anything in. Like, sine is the y coordinate. What's the y coordinate? So this is 1 over root 2 and 1 over root 2. So what's the y coordinate? 1 over root 2, right? And then cosine of 30 degrees. 30 degrees is right there. So cosine is the x coordinate, right? So what is the x coordinate of that point? How much do I have to go to the right? Root 3 over 2. And so you're going to get 6 times 1/2 plus 8 times 3/4. So what is that? 3 plus 6, 9. And don't forget to box your answers. Beep. Okay, come on, that's an insult to my loins right there. Cosine squared theta plus sine, I can put any angle I want there. Cosine squared theta plus sine squared theta is 1.
You made the problem.
What? Every test would have this on it. Every single one, because this is the most important identity in trigonometry. Of course, it's going to be in every. But you got to make sure these angles are the same, though. You know what I mean? They got to be the same. Just because you see cosine squared and sine squared, it's not always 1. It's only when these angles are the same angle. Okay, cosecant squared minus cotangent squared. We just did that over there on the practice quiz. I mean on the quiz. So if you remember anything, I think Mr. Park, this was 1 or -1, but you want to get it correct because if you get the sign wrong, like I said, if it's 4 points, you can get -3. So what do you think? -1 or 1? 50-50 shot. No, how about know the identity? What is the identity? Write it out. Cotangent squared theta plus 1 is equal to cosecant. Okay, so you're telling me right now, Mr. Park, I have a hard time remembering these. Is that right? Okay, thanks for speaking up. What would help you remember this? I don't know, to me it looks like, come on. That's just like knowing your name, right? You have to review your name every night. It's like when somebody's calling you, hey, Jeff. Are you walking down and going, Jeff? Wait, that's my name. Is that what you guys do? It's like you just know it. But see, that's the problem. You guys, how many of you laminated the identity sheet and looking at it when you're shampooing your hair? That's what I thought. I don't know, I'm trying to think of a way to memorize this. Did anybody come up with something?
You can't, you just have to.
No, I'm trying to think of a way to help you. I thought of it. Look, if it has an S in it, see, if it has an S in it, then it's all by itself. See the S? See? If it has an S, it's all by itself on one side. See, I just made that up now.
But it has a T. It's together.
Oh, good one. If it has a T, it's together.
What?
Because the T, see, the two of them, that's why.
Yeah, but
Together, so like you're holding hands. Together.
Just memorize it.
Yeah, I don't see the problem. It's not like knowing your name. Do I have to come up with stuff like this every single time for you guys? You guys are 11th and 12th graders. You guys are babies. Okay, anyway, so let's just assume we have these memorized. So look at this one. Look at this one. This is there. So if I brought this on this side, what would cosecant squared theta minus cotangent theta be? It would be 1. And then D, what is D? Tangent squared minus secant squared. Tangent squared minus secant squared. Okay, so I'm going to look at that one. What would happen, so tangent, what if I take the secant squared, bring it on this side, and I take this one and put it on that side, so what's the answer going to be? -1. I mean, whatever, do whatever you need to. You gotta get these identities out. Okay, next.
We're showing the work. You want us to write down the identity and the constant. Showing the work.
Yeah, that would be good. Okay, here we go. Hey, this looks like the problem on the quiz. Duh, it was. I just gussied it up. Cosine 5. Now, so look, this is 5 degrees, this is 5 degrees. Is there a way to change that to 5 degrees?
Fine.
Yeah, because when two angles add up to 90, then you can use the co-function identity, right? So cosine of 85 degrees is equal to what of 5 degrees?
Fine.
Sine, right? When two angles add up to 90, the cosine of one is the sine of the other. So,
Tangent 5.
so what is sine of 5 degrees over cosine of 5 degrees?
Tangent.
Tangent of 5 degrees. And what is armadillo minus armadillo?
0.
Anaconda. Oh my. You know, I copied most of these right out of the book, so if you did your book homework, but then see, that's the problem, yeah? That's the problem. What am I gonna do with this one? Well, again, when two angles add up to 90 degrees, now what is the radian measurement for 90 degrees?
Over 3.
Pi over 2.
So they may succeed.
Now, do these two angles add up to pi over 2? What is 1 pi over 12 plus 5 pi over 12? 6 pi over 12. That's pi over 2. That's 90 degrees. So these two angles add up to 90 degrees, which means the cosine of this one is equal to the sine of the other one, like that. So then, this is the problem that you have now. You see it? Okay, and then, see, the reason why you want the two angles to be the same, see like here, they're the same, then you can do things with it. Now what do? Try to remember what you did on the homework. I copied it off the board. Look, factor out a negative sign from these two, and what do you have left? Factor out a negative sign. Cosine squared theta plus sine squared theta, and then you should be thinking, hey, you somebody. That's 1. 4 minus 1, 3. Okay, gee, we're behind schedule here. 4 minus cotangent squared 20 plus secant squared 70. So either you have to change the 20 to a 70 or the 70 to a 20, right? Which one you want to do, doesn't matter, that's why. Because look, both of them add up to 90, right? So obviously in this section of the test, I'm testing you on the co-function identities. So you want to change this one to a 70 or this one to a 20? Pick one, somebody. Change that to 70.
Sure.
Okay, I wouldn't do that, but okay, so that is equal to what? When two angles add up to set a 90, the cotangent of one is the
Tangent.
tangent of the other. So this is your problem right now. And then you're supposed to go, you look at this and go, hey, you somebody. We just did the problem right here. Okay, look. What is secant squared theta? Maybe if you change the order then. Do we really need to change the order like this? I mean, if you have to. What is secant squared theta minus tangent squared theta? Right here. Okay, look at the identity right here. Here's the identity. What is secant squared minus tangent squared? What if I move the tangent squared on this side? What are you gonna get? 1. So this is equal to 1. See, that's the thing. In trigonometry, you gotta go, hey, somebody. 4 plus 1, 5. H. Okay, now H is probably the toughest of the problems in this section. Because this one you gotta know stuff. We had a problem in the book like this. Maybe do it on the board. You can probably figure out about it. Okay, so what happens is, see, this one and this one kind of go together. Okay, so here. Where's 50 degrees? Where's 50 degrees? You measure off a 50-degree angle, wouldn't it be about there? Okay, so that's a 50-degree angle. So cosine would be the x-coordinate. Whatever, I don't know what it is, but it's the x-coordinate of that point. It's this distance right here. Okay, now where's 130 degrees? If you measure off 130 degrees, it's going to be like what? It's like, what? 90 plus, no. 90 plus what equals 130? Again, so it's going to be like 90 plus 40, so it's going to be up here. Which of course means that, hey, that's a 50-degree angle right there then, right?
Yeah.
Cosine is the x-coordinate of that point. So even if I don't know what that number is, if I take this x-coordinate and add it to that x-coordinate, what's going to happen? Okay, now here. Okay, let's go back to elementary school. Here. Here's the point 3, 2. Here is the point -3, 2. See how like it's symmetric about the y-axis? If I add that x-coordinate and that x-coordinate, what do you get? You get 0. They cancel each other out. So like, if this is a 50-degree angle and that's a 50-degree angle, that means these two triangles are congruent. This side is equal to that side. So what can you say about this x-coordinate and that x-coordinate? One is positive gorilla, the other one will be negative gorilla. Don't they cancel out and you get 0? Because they're the same length, it's just that one, I don't know what the length is, but one is positive and one is negative, so they cancel each other out. Now what about these two? Where is 10 degrees? It's over here, 10 degree. Where is 190 degrees? It's 180 plus 10, so it's over here. Sine is the y-coordinate. So, hey, Mr. Park, isn't that a 10-degree angle there? These two triangles are congruent. What can you say about the y-coordinate here and the y-coordinate there? In other words, this and that. They're the same length, except one is positive and one is negative, so what do you think? They cancel each other out, and you get, what happens if you have an equation, everything cancels? 0. Mr. Park, I don't know what's going on, I just put 0 on the test. That's what you guys are thinking? Okay. You probably get 1 point for the correct answer, but then, like I said, you gotta show work. Okay, let's move on. Okay, here we go. This is just like the last homework we had. Is this the last? Is this the ending of the test? Or? Okay, if sine theta is equal to 3/4, okay, compute A cosecant. I'm gonna write all of them there. Cosine squared theta. C sine of negative theta, and then D cosine of 90 minus theta. So again, if you know your identities, this is not that bad. Okay, if you know sine, how do you get cosecant? Yeah, reciprocal. Flip it over, 4/3. It's easy. Okay, now what is cosine squared theta? Well, do we know an identity that has cosine squared theta in it? Yeah, cosine squared theta plus sine squared theta is equal to 1. So what is cosine squared theta equal to? 1 minus sine squared. Hey, but I know sine theta is 3/4, so this would be 3/4 squared. And what is 3/4 squared? 9/16, so I get 1 minus 9/16. Change the 1 to 16 over 16, and so we get 7/16. This is right out of the book, people. I just copied it out of the book. I changed the number. I think on your homework you had 1/4. They just put 3/4. Okay, sine of negative theta. There's an identity for that. What is that? Negative sine theta. Well, if sine theta is 3/4 then, so what is this equal to? Negative 3/4. And then finally, what is the cosine of 90 minus theta? That's on the identity sheet. Don't worry, I'm going to know it on Tuesday's part. Sine theta. When two angles add up to 90 degrees, the cosine of one is the sine of the other. So what's the answer? Look, it's right there. Sine theta is 3/4. That's sine theta. This is 3/4. So are you telling me that I need to memorize the, yes! You need the top 1/3 of the identities need to be memorized. Okay, is this, yeah, we're almost done. Okay, this is taking longer than expected. Number 7, cotangent theta is equal to 2. Compute tangent theta, cosecant squared theta, tangent of negative theta, and the secant squared theta. Okay, what is the relationship between cotangent and tangent? They're just reciprocals of each other. So if cotangent is 2, flip it over and you get, here, 2/1, flip it over. 1/2. That's like the easiest 4 points you can get. Okay, cosecant squared theta. Now, is there an identity that I know that has cosecant squared in it? Yes, cotangent squared plus 1 is equal to cosecant squared. Now, I don't care how you memorize it, you gotta have it memorized. All by itself. Whatever. Anyway, this is what we're trying to find. So, if cotangent theta is 2, if this is equal to 2, so 2 squared plus 1 is equal to cosecant squared theta. There we go. What is 4 plus 1?
5.
5. Okay, finally, tangent negative theta. Okay, what's the identity for tangent of negative theta? Negative tangent theta. Yeah, but we just figured out tangent theta right here. So the answer is negative half. And then secant squared theta. Okay, now this one I put in last problem. We gotta do maybe some work, yeah? What is secant squared theta? 1 over, what is secant? 1 over what? Cosine, so cosine squared. Yo, Mr. Parker, I don't know what cosine is. Yeah, so that's why we gotta do some work. Well, look at the Pythagorean identity here. Here it is. Look at that Pythagorean identity. What is cosine squared equal to? If you take the sine a little bit on this side, well, here it is right there. It's 1 minus sine squared. Do I know what sine squared is? Yes. Because look, this is cosecant squared. Cosecant is the reciprocal of sine, right? So if this is cosecant squared, 5, what would sine squared be? Flip it over. How do you flip over 5? 1/5. And of course, 1 minus 1/5 is 4/5. And what's 1 over 4/5? 5/4. 1 over means reciprocal. Okay, that one was probably the hardest of it. See, so it's really not that bad, this test. So, if you didn't do the practice test on your own, yeah, okay, yeah, you copied everything down, you're gonna get full credit for the homework, fine. But then the test is worth 100 points. So, I would do the practice test again by myself. Monday night is probably the best night to do it, since I'm not seeing you on Monday. And then what if you get stuck on this? What if you get stuck? I forgot how to do it. Well, most of you wrote down what to do, but then how about watch the video that we just made? Yeah, that's what I did. All right, we're done for today. I thought we were gonna finish much earlier.
See you next